This meeting is being recorded.
Welcome everybody. Welcome to our online attendees as well. This is our Space to Breathe event, getting answers from satellites. We have people in person, both here and at our sister centre in the northeast, and we obviously have quite an online contingent as well. I just want to highlight that this event is being delivered by ourselves at South Coast Centre of Excellence in Satellite Applications, but also our sister centre, the Northeast Centre. So just some quick housekeeping. For those in person, we're not expecting a fire alarm today, but should we, me and my colleague Chloe will escort you out of the building and round to the car park, which is the muster point. Anybody who needs a quick break in the loo stop, it's just round on the left-hand side of the reception. For those online, this is a webinar session. It is being recorded. Please do introduce yourself in the chat box at the bottom of the screen. And if you have any questions throughout the session, we'll be addressing those at the end. So just pop any questions in the Q&A section. Okay, and I think that's all in terms of housekeeping. Right, so the agenda. So for today's webinar, we are ably assisted by a fantastic group of speakers. We've got Dr. Thomas Brown, the Director of Research for Portsmouth Hospitals and University Trust. We've got Dr. Olusegun Fawali from the University of Portsmouth, the School of Geography, Environment and Earth Sciences. We've got Suzanne Collins, Bid Manager from 4Earth Intelligence. And then online we'll be joined by Rowan Lee, Technical Director at EarthSense, and Emma Hatton, a Satellite Solutions Architect from the Satellite Applications Catapult. So without further ado, I'm going to be joined by Thomas Brown, who's going to take it away.
Brilliant, thank you very much. Good morning, everyone. It's a real pleasure to be here this morning to talk, and thank you very much for the invitation. So I've been asked to talk a little bit about air pollution, but more focusing on the prevalence of respiratory disease. I'm a consultant respiratory physician at Portsmouth Hospitals, and these are my disclosures. So many of you be from Portsmouth, but Portsmouth's obviously a fantastic city, home to HMS Victory, the Spinnaker Tower, but also to our severe asthma service. So the way asthma services work in the UK is that we have 14 severe asthma services, and one of those is based in Portsmouth, where we provide care for people with severe respiratory diseases. So thinking about air pollution, this isn't a new problem. So we all know this problem, and this dates back, this is probably the most famous case, so this dates back to the Great Smogs of the 1950s. And we know that as a consequence of burning fossil fuels, lots of people burning coal and things within their homes, huge peak in deaths was seen as a consequence, not just at the time, but also subsequently. Killed more people than cholera, and it led to the Clean Air Act. So there have been several iterations. But nevertheless, these caused a really good and sustained reduction in many of the emissions that were killing people at the time. This was an absolutely fantastic outcome, but the trouble is that led to complacency. And since then, we've really thought, well, we've cracked air pollution, it's not a problem. But actually, that's really not the case. So just thinking a little bit about chronic respiratory diseases globally. So these are a massive issue. So if you look at some of these reports about the kind of prevalence and the burden of these conditions for people across the world, it affects a huge amount of people. So 545 million people affected. But I think most startling is the rate of increase in these conditions. So if you look to 1990 and 2017, what you can see is a huge increase over that period of time. So nearly 40% increase. The most prevalent of these conditions are COPD and asthma, which I'm going to come to talk a little bit more about, but also the effect that these have on people. So nearly 4 million deaths in 2017. And again, a very steep rise when you compare that to 1990. So we're still seeing huge problems worldwide with chronic respiratory diseases. But also they're causing a huge detriment to people's lives as well. So if you look at disability adjusted life years, so these are life years lost due to disability, you see a huge amount of impact. And if you look at the map across the world, you can see it's very different in different parts of the world. And we've got to understand that because it has really different impacts on different societies. And it's really important that we also understand that the UK is by no means immune to these problems. Still a huge problem in the UK. But if we think about Southeast Asia, seeing huge amounts of people with chronic respiratory disease, but also sub-Saharan Africa as well. And these are areas where we're seeing huge rises in these problems. And I'm focusing on asthma and COPD today, but really also lung cancer, interstitial lung diseases, which are scarring of the lungs. We're also seeing the prevalence of all of these conditions rising. So what do I mean by chronic respiratory diseases? Well, I want to think just a little bit about COPD. So many of you may be familiar with COPD. So this is a combination of chronic bronchitis and emphysema that has a huge impact on our patients' lives. And we know that massive numbers of patients have this worldwide, and it's the third leading cause of death worldwide. It costs the NHS each year about £800 million to look after it, the majority of which is caused by exacerbations where symptoms get worse and people need emergency treatment for their COPD. It causes a huge number of admissions to hospital, and you'll all have seen on the news that NHS hospitals are being overwhelmed, emergency departments really struggling to cope with the number of patients coming through. And we're really seeing this with conditions like COPD causing huge numbers of admissions. We also know that a lot of patients who come into hospital, when they do exacerbate, what sadly happens to them afterwards is that we think, yeah, okay, you've got home. But actually, when you look at the longer term outcomes, these have really significant impacts on people. And you see, sadly, about 40% of people, if they've been hospitalized with an attack of their COPD, actually they're either readmitted or don't survive for 90 days. So we've really got to understand what's causing these kind of attacks and how can we address it. We know that it's more common in older populations, and it's usually causally linked to cigarette smoking. That's what the assumption's always been. But actually, we know worldwide, but also in the UK, there are a huge number of other causes for COPD. And we know that actually around the world, the burning of biomass fuels in homes is actually a really significant problem. And this is burning for heating, but also for cooking. And this is a bronchoscopy. So this is where you put a camera down into somebody's lungs to have a look. And you can see here, this was a lady from Afghanistan who'd been sleeping next to a biomass burning fuel at home. Well, she'd been burning it at home. And you can see here this blackening of the airway, which is pointing with the arrow there. And that is literally the impact of breathing in that biomass fuel while it's burning in the home. And you can see the blackening and scarring that causes. So quite evidently causing huge damage to the lungs. And also over here, you can see, so this is emphysema up here. And just to highlight where the arrows are, what you can see there, these are holes occurring in the lungs. They occur usually in the top of the lungs, because when you breathe in, that's where those air allergens or particles are having the major effect of damaging the lungs. So also thinking about asthma. Asthma also has a huge impact, 300 million people worldwide, causing a huge number of deaths for a condition that should really be treatable. We know that we still have some of the highest rates in Europe. 5.5 million people in the UK have asthma, and we know there's still, sadly, 3 people die each day due to asthma in the UK. Huge number of hospital admissions, but probably most concerningly, deaths from asthma are actually rising in the UK. They've risen by about a third over the last decade, and that's despite huge amounts of work to try and improve outcomes for patients with asthma. Huge national review of asthma deaths, trying to work out what we can do. So what is asthma? Well, asthma is caused by, you can see here in this top picture, it's a picture of somebody's lungs. These are the airway tubes in the lungs. It's caused by inflammation of the airway tubes. And what you can see is when somebody takes a breath out, these airway tubes are narrowed, they can't breathe the air out of their lungs. And you can see here in these pictures lower down, this is about the inflammation. So this is a normal airway. In asthma, the airways become very inflamed. And of course, this is the main interaction we have with our environment. The other problem in medicine is we talk a lot about air quality and air pollution, but what are we actually talking about? So most of the time in the UK, we're talking about modern kind of day pollutants. So we're talking about particulate matter, usually smaller ultrafine particles, oxides of nitrogen and ozone. And that's the main thing that we focus on in terms of UK practice. And we know that there have been huge increases in the amount of nitrogen dioxide and particulates that are coming out of diesel engines. And this is what we're seeing as a particular problem as well, particularly in the kind of healthcare systems. And a lot of the work looking at whether pollution is increasing the prevalence of respiratory disease is quite focused around those kind of particulate exposures. And we know that this is, causing a problem. We know that for older people who live near busy roads, it speeds up the rate of lung function decline. So we're seeing an increasing number of people being shifted into that zone of having disability due to loss of lung function. But also things like microplastics are becoming increasingly recognised as things that can damage the lungs. And these have been implicated in asthma and COPD, but other lung conditions as well. But also we're talking about pollen counts, air temperature, humidity, things that have a huge impact on our patients. And some of you will be familiar with the concept of thunderstorm asthma, it's a particular problem in Australia. So what happens in thunderstorm asthma is you get this sort of perfect storm whereby you get pollen grains being swept up into the air. They then are essentially degranulating, those fragments of pollen are then just spread across a very wide area. Causes a huge amount of people suffer exacerbations with their asthma, and it can overwhelm the healthcare system very quickly. But the other issue we're seeing as well is indoor air quality, which I think continues to really be ignored somewhat. So when we think about modern day pollutants, what are we really talking about? Well, I think we've described what they are, but how can this really impact on your lungs? Well, a person breathes about 250 million litres of air each day. During their life, but what we know is this is the main interface we have with the environment. So you're going to see a huge impact in terms of the body. And of course, that perhaps makes sense in terms of the lungs, because we can all imagine that. But it's really important to recognise that air pollution has been linked to a huge amount of things. So yes, cancer, asthma, but also cardiovascular disease. Some of the very small, fine and ultrafine microparticles, they can get into the circulation. Links to diabetes, obesity, but also now links to cognitive change and dementia as well. So a really huge impact on the human body. We also know that there's a huge impact of air pollution in the UK. So we're seeing a very significant mortality burden as a consequence of that in the UK. So it's equated to about 40,000 deaths. But we also know that it's very expensive. So these conditions, these long-term conditions, cost a lot of money to the NHS to look after. But it also can affect you at every stage of life. And that literally is all the way through. So actually fetal development, air sacs are developing in the fetus at a very early phase. And as they develop, there can be damage to that developmental phase. And you can see really significant problems. But there's very strong evidence as well that this kind of outdoor air pollution suppresses lung development in children and also can cause a lung function decline in adults. So as you get up to about the age of 18, your lung function is increasing. Beyond that, everybody's losing lung function, but at a very slow rate. But what you see with exposure to air pollution is that can happen much faster. But in children, they might never reach that peak of lung function. So they're never going to have fully developed lungs. And that's a huge problem when you think about the impact that's going to have as people live longer and the population ages. But we know we can actually do something about it. So children living in these very highly polluted areas in this study from California had quite significantly reduced lung function. But actually, if you improve the air quality, you can reverse it. So there is evidence emerging that you could do something about this problem. So it's not just something we should be accepting. There's also quite clear evidence that's emerging that exposure to air pollution, if it's over a prolonged period of time, is associated with the new onset of asthma in adults and children. So it's not just that it might be deteriorating lung function, it can actually cause these conditions. And that's becoming increasingly recognised. And this is just a load of studies really that demonstrate some of that kind of impact. But you can see now large meta-analyses, so 19 studies demonstrating that if you increase the exposure to particulate matter, you can actually get new onset wheeze, but also you can see the same in terms of new onset asthma. But also a large study that was done, this Swiss study, which was done on a big cohort looking at what the impact was over about 11 years of exposure to particulates, demonstrated quite clearly that there was evidence of increased new onset of asthma. So what are the consequences? Well, if you've got an underlying health condition, so this, we know that air pollution can cause deteriorations in lung function, it can cause new onset of asthma and COPD as well. But also, if you have these conditions, it can really exacerbate them and make them worse. So if you have an underlying health condition, exposure to pollution is actually a really bad thing for you. Patients with asthma experience more symptoms because they have these triggering phenomena within their airways, which are hypersensitive, and they react to that. But also these patients may require more treatment. They may suffer more exacerbations. So the problem with more exacerbations is obviously when people exacerbate, that's a very severe impact on that patient. It's a horrible thing for a patient, but also they may well need significant treatments in the hospital setting, for example. So it's really a question of trying to manage that effectively. In COPD, we also know that people who are exposed to these high levels of air pollution do also have a more rapid decline in their lung function, but they again are more likely to suffer attacks The important thing with COPD is each time you have an attack, there's a deterioration in your lung function. So actually we're seeing a progressive decline for these patients over time. So where do satellite technologies have a role? See, that's probably for you guys to say, but nevertheless, these are my kind of thoughts really about where they might or do currently have a role. So we know that there's a lot to be said about air quality information that can be gained from satellite technology, but there are other things as well. So obviously things about, you know, using the location of people to try and work out. We say to a lot of people, I must say 100 times in my clinic, it's really important you take regular exercise, because it might well not be the person's health conditions deteriorating. It may well be the consequence of doing less of physical deconditioning that means they're becoming more breathless. But I've got no way of knowing. Did they do anything about that? Did they go out walking? Did they do it? Can I tailor an exercise program for this individual? No. So therefore, you know, it's really challenging to do that. And there aren't really technologies that can actually tell you, yes, a person did that. People use step counters and other things, but that's quite challenging to know. And also, there's no really good kind of way of knowing, well, you know, they're worried about doing, where should I go? Where's the air quality better? So actually, a way of saying where somebody should be taking their physical activity, but also making sure they actually do it and encouraging people and incentivizing people to do it. Trigger identification is really key as well. When somebody's lung condition deteriorates or starts, we need to know where they are and what's happening in that environment, because it could well be something that's triggering them. So is it an area of high pollution where they are? Is it an area where there's a high pollen count? Is there something else going on in that area that we can attribute to why their conditions deteriorated? And that would be absolutely key for a lot of people, because trigger avoidance is really important in asthma, but it's so difficult to avoid so many triggers because you simply don't know they're there. Remote monitoring, we're seeing a huge amount of remote monitoring coming through in various kind of guises, but there are issues, particularly in rural areas, about making sure there's that continuity of communication. I think early detection of things like thunderstorm asthma, knowing that's going to happen, the Met Office tries, but as the Met Office maps often very vague, they often split the country into about 10 areas. Very difficult for a patient to actually make any kind of real assurance for themselves that they can go out and do what they want to do. And then the other thing is about real world data. We need real world data to influence government policy. It's an absolute disgrace that we're exposing children to huge amounts of air pollution, which is damaging their lungs. And yet, actually, it's really an under-recognized, if not unrecognized problem, particularly in the media. The final thing I just wanted to say, for those of you developing technologies within the NHS, is that the landscape of healthcare is yet again changing, but there will be very significant changes now with the introduction, and these have now come into force as of last Friday, of integrated care systems. So the UK has been split into 42 integrated care systems. This is a very dramatic change on the way it's been delivered before, although perhaps lends itself back to some historical mechanisms we've had, with some very important differences. One is we will now have ICBs. ICBs will be there to continue to fund and manage NHS budgets and to commission services, but we will now have integrated care partnerships, so a much greater focus on all the other kind of systems that feed into healthcare, so social care, city councils, all those kind of bodies, making sure that that's represented within this partnership, and a much greater focus on population health. So not just each provider organisation focusing on its needs, but hopefully a system-wide change for benefit. There's a really good kind of visual about this on the King's Fund website, which I've included there if anyone wants to have a look at it. This is key. If you want to develop a technology in the healthcare system now, you have to map it to this system, otherwise it won't be funded. Just wanted to talk very briefly about the PTTU. So the PTTU is our technology trials unit in Portsmouth, so it's a collaboration between the hospital and the university, where we're really looking at testing, usually with SMEs, but with commercial partners, novel healthcare technologies. Just a couple of things I just wanted to highlight, because these are things that we see time and time again. Really important to work out how the technology aligns to the care pathway. There is no point in having a technology that doesn't align to the care pathway. Now, you can change the care pathway, but you've got to work out how that would work and how it looks. Lots of people bring us remote monitoring solutions. That's fine, but if you don't have an infrastructure to do that remote monitoring, you can't suddenly fund an entire new ecosystem within the health service to look after that system. It's got to be incredibly clear what the benefit of the technology is to the patient, to the clinical service, but also the wider system. And that's absolutely key now. You have to demonstrate system benefit. It's also got to fit with the NHS long-term plan. This has become the sort of Bible that will be updated in a couple of months, but nevertheless, this is what everyone is measuring the metrics of success against. It's incredibly important you understand what part of the system is going to pay for the technology. Lots of people come assuming that there will be a pot of money that will pay for it. Actually, you've got to work out exactly where. Who are the benefits? Where are the benefits? And how can you then introduce it within the system? And who are the commissioners? And how are they going to actually commission the service you're suggesting? And then the other thing is, can you really evidence the benefit? We see so many studies that say, we will prevent 20,000 admissions across the UK. That's absolutely fine, but you have to be able to demonstrate that within the healthcare system for a funder to actually provide it. And I just say that because we see brilliant technologies coming along, but they just jar slightly with the way the healthcare system is set up. I think it's really important to speak to people within the healthcare system when you're bringing that through, so that the studies that you do, because we know studies are expensive, they take time, or service evaluations, they need to be set up in a way that will demonstrate the benefit you actually want to show. Sorry, that's it from me. I've left my email address there if you want to ask me anything.
Thank you, Tom. That was a fantastic presentation. It gave us some really, really good context for the challenge around air quality, what it actually means, as well as some insights to NHS and about how technologies can be integrated into that system. So I think that's a really, really good starter for 10. Next up, we are joined by Olusegun Fowali, who is going to be talking about his work using satellites to measure various particulates and drawing on projects involving West Africa. Olusegun, take it away, please.
Thank you very much, Louis. Yeah, it's a privilege to be here. I know it was a sort of coincidence because you actually spoke with Mike to be here and just invited you to me. Anyway, I think it's today a good opportunity to say some of the things I've done. By the way, I'm Olusegun Fowali. I'm an atmospheric scientist, and what I do basically is I monitor air quality using ground-based instruments, different devices, and I use satellite as well. So I'll be talking briefly in the next 10-15 minutes about monitoring air quality on space, prospects and drawbacks. And Thomas has laid a very good foundation for my talk. I'm not going to do too much of talking about why we need to do it. First, I will try to do a brief overview of ground-based air quality monitoring and highlight some pollutant sensors on satellites. There's a study I did in Africa during COVID, a regional assessment of air quality using satellite from data, then some drawbacks. Satellite data were discouraged, and I'll do a conclusion quickly. All right, air quality monitoring, like Thomas has highlighted, it's non-negotiable. You just have to monitor air quality. Individuals now do it because there are local sensors you can use, monitor it on your own, and it will give you a fairly good understanding of what the air pollution is like. So it's not negotiable. The earth impact severe, climate impact is telling on all of us. We saw what happened in Germany last year. The flooding was massive, certification here and there. So those are the climatic as well as the earth impact of poor air quality. It's a massive problem. I tell people we have created and we are struggling to remedy what we created. So now limitations of ground-based measurements. You've got to monitor, but there are limitations to it. There are stations I landed at about 10 or 15. I'm in Portsmouth, by the way. My first visit in Portsmouth was December, so I'm still less than a year. So I don't know my way around that much. I landed at about 10 or 15 monitoring stations in Portsmouth for air quality. All right. That's fine, but still there will be some limitations when you talk about having a clear view of what pollution is over Portsmouth at a particular time. You are limited in terms of what you measure. That's where satellite data comes in, will be an advantage. Now, one is not always available, not always affordable. That's the ground-based measurements. It can be very expensive to set up. In the last decade, I think, low-cost air quality sensors are trying to revolutionize what we do with air quality, but still at that, it can be very expensive. That's ground-based measurements, low spatial and temporal coverage. You have a if I have a monitoring station somewhere, it's limited in terms of what it can measure. Then inadequate for studying transboundary air quality problem. There is no barrier, there is no wall that stops air pollution. Air pollution from South Asia affects the UK. We can't stop it. Okay? Monitoring, ground-based monitoring stations cannot study that. You need something broader than that. And lastly, it's inadequate for regional air quality. Those are limitations for ground-based air quality monitoring. And that is where satellite monitoring comes in to augment, all right, to complement some of these shortcomings. There are a number of satellite-based sensors that monitors air quality. It's amazing technology that has been around for, I think, since the 80s. And I'll talk about some. By the way, the list is not exhaustive. I've added and so on. AOD that's the aerosol optical thickness. It's a measure of the amount of particulate in a column of air from the ground to the top of the atmosphere. All right, and that is AOD. It's measured by several instruments. Several satellite does that. MODIS is one. MIRS is one. MODIS is, by the way, moderate resolution imaging radio spectrometer. Tropomi does that. OMI. Now this ESA is the European Space Agency. Put the instruments and the agencies that have them on their satellites then in the brackets. So AOD will tell us the amount of aerosol in a particular column of air at a particular time. Although it will not tell us, like we said, not tell us about the size fraction, ultrafine, fine, no, but to give us a sense of what the amount of aerosol is. And there are studies now that try to estimate PM2.5 from AOD. These are two beautiful guys that did something that was amazing. They were able to estimate, might not be accurate, but give you a sense of how much of fine particulate you have in the air column at a particular time. NO2. NO2 is one of the highest trigger of asthma and COPDs. And it's basically anthropogenic in nature. We generate it. It's not natural. We can't do anything about the natural pollutants, but we can control the anthropogenic pollutant. NO2 is measured by tropomi. Tropomi is a tropospheric monitoring instrument. It's on Aura satellite. You have OMI as well. These are instruments that measure NO2. There are others that are now commercial instruments that measure them. But most of what I'll talk about here are the ones that are really available. You can access them at any time. Now, methane, tropomi, and ERS. These are the two mostly the ones I've used before. There are others. Then there is one I just found out, the GAG-SAT. I just found out maybe about two. I think you told me about that. Liz told me about that. And I read about it, so I put it in red. It's a commercial satellite. But the beautiful thing is they can go down to just about 25 meters. That's very great. Very great. That revolutionized remote sensing on satellite. Most of these, the other ones, the conventional ones can go between 100 kilometers to 25 kilometers or 10 kilometers at best. But GSG-SAT can go to 25 meters. So these are some of what we can have in ozone. Of all these pollutants, ozone is not a primary pollutant. It's not emitted from any source, right? It's generated in the atmosphere by precursors and given the right atmospheric condition, ozone is generated. It's also another very serious trigger of COPDs and asthma. And it will interest you to know that ozone will also greatly retard the growth of plants. So when you talk about food security, ozone is a great danger for food security. So ozone is measured on OMI, on ARS, on tropomi. These are instruments that measure it on those satellites. Carbon monoxide as well. And lastly, SO2. All these are anthropogenic pollutants except ozone. All these are measured on satellites. Okay. So I will talk about a study I did during COVID. And the idea behind the study was, formaldehyde, another one as well. Formaldehyde, this is basically from industrial emissions. It's also a serious pollutant, although understudied, but it's a serious pollutant, especially for human. Now, there's a study I did during COVID with some colleagues all over Africa. I think we are from about 7 or 8 countries. We wanted to see what was the air quality before COVID and what it is during COVID and even after COVID. Try to do a comparison, but we stopped. There were no ground-based stations to do that. All right, there were no ground-based stations, and it's okay. We can do something. Then we resolved to working with satellite data. It's not very creative. Okay, these are the countries. There were 7 countries. By the way, I'm from Nigeria. I'm originally from Nigeria. That's Nigeria. We talk about Nigeria, Cameroon, Burkina Faso, Mali, Gambia, Senegal. There were 7. There were 7 countries. Okay, Ghana. Ghana is the 7th country. So we want to see what was the impact of the lockdown on air quality. We examined 7 pollutants. First, we took AOD data from Moody's. We tried to compare what was the situation 3 years before 2020, 2017, 18, and 19, compared it with 2020. And for the average of that 3 years is what we have there. That's what the pollution level is like. AOD is usually from 0 to 1. The closer you are to 1, the more polluted the atmosphere is. All right, meaning very low AOD will generally mean a very clean atmosphere. But when you have AOD around 0.8, 0.7, that tells you the atmosphere is hazy and very dusty. So you can see from there, okay, yes, I think I have, okay, sorry. Now, if you look at these spots here, those spots are in the range of 0.8, meaning those areas are highly polluted. Ground-based measurements may not show this, all right, because each of those rings will be about not less than maybe 1,000 square kilometers. Each of those red rings, about 1,000 square kilometers. Okay, you need a large network of ground-based measurements to do that. These are some of the limitations of ground-based measurements. So with this now, when we study from the air, we can now come down, okay, this area, let's see what's happening without bringing monitoring station, bringing network, and we can now assess, go down to the nitty-gritty of the causes of this thing. Those are some of the benefits of ground-based measurements. So we now try to subtract, what's the difference between these two, before COVID and after COVID. Okay, so we saw that around some of the towns, around some of the countries, we did a regional air quality and we went down to the epicenters. I'm not going to talk about the epicenters, I'm talking about the regional now. So that there are reductions around some of the epicenters around Bamako, Kodiogo, that's Bamako, is Mali, Tuba is Senegal, Kodiogo is Burkina Faso, Accra, Ghana, Abidjan, Cote d'Ivoire, Cameroon is there, and Lagos is Nigeria. So these are some of the beautiful things we do with satellite data, where ground-based measurement might be limited. Now for carbon monoxide, we did the same thing. One beautiful thing came out here from we see something where I'll try to probe this further now, but that will not be from satellite data. We'll see that from the 2 rings, they suggest something to us, that the CO that comes into this region is probably a transport from somewhere, which we are thinking is biomass burning from Central Africa or from South Africa. It's a transport from somewhere. You can see in both the 2 rings there, it's transport from somewhere, which disperses, it's an intrusion coming up, and you can see the further you go, the less the concentration. Okay, so that is something I want to prove further now. It's an offshoot from this study, and The difference between that to 2017 to 2019, the average of that 3 years, and 2020, we try to compare that. That is what we found. And we say that on the level of decrease for CO during COVID was not that pronounced, mainly because most of the CO were not local, they were import, transboundary. So the impact for the lockdown was not that too pronounced for CO. Oh, sorry. Okay. All right. What's happening?
Oh. That's new.
Okay, is that where we are now? Okay. Oh, good. All right. Sorry for that. And now for SO2, we did this for 5 pollutants. And for SO2, something, and if you look at where we have the high concentrations around there, we're actually around the ports. That's around the ports. That's the port around Cape Verde. That's the port around the Atlantic. So here's still something. That could be for ship. Because around here you have big ports. You know. That could be from the ship. You know, they burn a lot of heavy oil, and they stay around the port for long weeks before they are offloaded. But definitely we see around the coastal area, SO2 levels are high. And if these are not measured on the ground, how do we know? Because the air quality measurement is not too pronounced here. You can have maybe 1 or 2 in large cities. That's grossly inadequate. Okay, but from satellite now we can see clearly with this data that SO2 values are high around the coast, which can now be probed further with ground-based measurements. That's the beauty of studying from the top. And that gives rise to significant decrease there during the restriction period. Significant decrease around that belt there. Ozone. We took our ozone data from Earth. It's another instrument on the, I think it's on Terra satellite now. And this is what we got, For 2020, ozone increased. While other pollutants are decreasing, ozone increased. Look at the two belts. It's darker on the right than it is on the left. So the values for ozone was high during the lockdown than it used to be. Ozone is quite a complex air pollutant because it depends on a number of things. Increase in temperature can cause a spike if the right precursors are there. All right. And if it's basically from CO, VOCs, and oxides of nitrogen, there can be forward or backward titration for ozone. So ozone is quite complex. But what we know is that for 2020, there is an elevated level of ozone in the atmosphere than it used to be the preceding 3 years. That's another thing you can prove further, but this is just a generic study. Okay, significant decrease there. Comparing the 2 years, we have significant decrease. You can see about 3 dopsins for ozone across the cities there. NO2. This is opposite to what we saw for ozone. Here on the left is darker than it is on the right. These are things, beautiful things you can see from satellite. You might not see on the ground. If you want to see this on the ground, you have a very dense network of ground-based measurement, which could be expensive to put together. Right? That's NO2, and the difference is, you see there and there, it's darker here than it is there, darker here than it is there. And the difference as well is because across the region and the epicenter, there is a significant reduction in the level of NO2. Also, I didn't say at the beginning, this study should be published in a week or two. It's been reviewed and is in the last stage of publication. Now, some major drawbacks why some people are not too keen on using satellite data. All right, lacks information, you can't discuss the particle distribution. So satellite will not see that particle distribution. No, you can't know the composition because when you study aerosols, I don't know what's that. Am I running? Okay, when you study aerosol, you need two things. What's the mass per volume of air? Okay, that tells you what the concentration is, and you want to know what the composition is because. But satellite will not tell that, and there is gap in spatiotemporal coverage due to cloud. There are some months in the year where they're missing data for satellite. And lastly, there can be over or underestimation. I'm not talking about the first two because you might not be able to control that, but I'll talk quickly about the second two. Now, this is where ground truthing comes in. You can use ground-based data to sort of compare what you have from satellite. This is a study I did while I was in Sweden, 2020 and 2021. Now we had MODIS, we have satellite, we have data. This is actually MERA2. MERA2 is a combination of historical satellite data and model data. So we actually compare that against ground-based measurement from Aeronet, and we can see things like this. Although Aeronet is relatively new, but with what we have for Aeronet, we can see ground-based measurements and from MERA2 gives a very similar, not too different. Because when you want to talk about this, people say, have you compared to ground-based data? So we did ground routing for this, and it was okay. Same again for this. There are 5 and ground-based measurements. So you need things like this to actually say, okay, my reading from satellites are okay, they are not that bad. Okay, they might not be perfect, but they are not that bad. When you do this is ground truthing, and it's actually enhancing the acceptability and usage of satellite data. Okay, that's just obvious. Those are the conclusion. I want to stop here 2 minutes. Thank you very much.
Right, thank you, Abhishek, and that was actually really, really insightful and showed us, yes, the power of satellites and being able to look at really vast areas of information, and also showing that kind of temporal aspect as well, of course, looking over time periods as well. Yeah. Okay, next we are joined by Suzanne Collins, Bid Manager for Earth Intelligence. So, Suzanne, if you'd like to come up, thank you.
Good morning, everybody. Hi. I'd just like to thank the organisers for inviting For Earth Intelligence to talk today, and it's a real pleasure to represent them. My name is Suzanne Collins. I've been working in the space industry for 5 years. I started out in satellite manufacturing, which is the upstream space market. Last year, before COP26, I wanted to be more active in my personal commitments, and so I moved into the downstream satellite applications industry, specifically focusing on geospatial intelligence for environmental applications. My role's not technical, so I'm commercial, and I focus on customers, what their needs are, what their problems are. So it's very interesting to hear some of the problems that we have, and solutions, and pulling those together in a way that works for the customer. I'm also representing Space for Climate today, of which 4EI is a member of. And I'd like to thank them for asking me to present on their behalf. They're chaired by the UK Space Agency, and it's a not-for-profit membership organisation. The members span across all organisations from SMEs to large multinationals, academia, non-government organisation, government agencies, and also funding vehicles or organisations. What we're trying to do is to really bring all of the different space data, climate assets together in one place, and also to promote the UK as a provider of climate space data around the world. And membership is open to any organisation registered in the UK, and also will be using the data or can enable the data and make it accessible to everybody. And you can find out more about them on the links at the bottom of the page, and I have an email at the back of my slide deck. So just to give you a little introduction to 4Earth Intelligence, and this is our mission statement that you see on the screen today. We're known as 4EI for short, and we've been active for about 8 years with offices around the UK. So our head office is Bristol, and we have an offshoot office in Cornwall looking at the offshore renewable energy market, and an office in Brighton looking at sustainable finance. We also have another office in the Middle East, in Abu Dhabi, in United Arab Emirates, with the primary customer there being the Environment Agency, who are very active, I must say, in environmental applications. And what our approach is to make satellite data available to everybody. So it's no longer belongs to the few. It's about sharing all of this data sort of democratically, because information is a powerful tool for change, especially when we share it widely with everybody. So our focus is on getting this space data out to people in a format that they can easily access it and use it in a friendly way, which will enable those people to get started using the data without any barriers at all. And most importantly, the focus is on the information and the valuable insights that can be drawn from out of those data, because just looking at data, it's the interpretation and the answers that it provides is where the power is. And it can really transform organisations powered by their space data. And our core capabilities are based around Earth observation and remote sensing. But we also have a strong team of software engineers in the AI, machine learning, deep learning environment, along with geospatial mapping. And we invest our time not just in customer projects, but also in R&D projects. So we have some of our R&D projects on the screen there. But I'm going to focus on 2 examples of where we're using satellite data in a product form and applying it to environmental applications for air quality and also for heat mapping, because both of these are linked to health and to populations. So firstly, air quality. 4EI is harnessing very high resolution satellite data to provide novel air quality modelling tools. So what's the need? Well, we discussed about air quality being a global issue. It's a huge health burden. It's increasingly in the news, and we hear about the impact it's having on our health, our children's health, particularly in cities, but we don't necessarily have the right information available to us, considering it's a topic of such great concern. So in terms of available data, what 4EI has observed, and has been pointed out actually, is that having a comprehensive coverage of data is a challenge. And so we have leaned towards modelling data that can be a lot more comprehensive. And what we're talking about there is the fact that monitoring stations are great at recording in specific locations, but they can't bridge the gap between what's happening between those locations. The thing with modelling is it allows you to see the data with comprehensive coverage across a very wide area, but it needs to be very good detail, high level of detail, and we need to go right down to the street level. So where does air pollution come from? We've looked at that quite a bit this morning. So give a basic example over London. Obviously, it's different from place to place. So on the left-hand side, we have multiple inputs at approximately 50%, but over on the right-hand side, we have one of the primary contributors, which is road transport. So how do satellites help with that? So what you're looking at on the screen is zoomed in satellite imagery. And on the left, we have a 50 centimetre imagery, courtesy of Maxar. And on the right, we have 30 centimetre imagery, which is from Airbus. And from that imagery, so what that relates to is that for every pixel that you can see is 30 centimetres on the ground. And you can clearly see from both pictures the carriageways and the vehicles, and particularly so with 30 centimetre imagery. And so we're able to look at the from the ground at the street level, which is very, very important for our models. So how does this equate to air quality modelling? Well, 4AI developed an algorithm using machine learning and deep learning that automatically recognises and counts the vehicles within the satellite image. And you can see them highlighted in green and red and blue on the screens. It doesn't just recognise and count them, it understands whether the vehicles are small, medium or large, because it has, for the model, it has different input for the amount of emissions. But also it interprets whether it is moving or if it is parked and stationary, because that also plays into the air quality model. And all this data is coming from satellites. How do we use that data? Well, that vertical data is fed into an air quality model, but it's actually just one source of data. There are multiple sources of different data that are being fed into this model, including meteorological data, emissions catalogues, a wide range of different inputs, but I haven't focused on that today because of some of the time issues. The end result of this is, as you can see, it's an easy to interpret map of a European-wide air quality model. And what the vehicle data has done is they've been able to take it from a very large area down to a street level and build back up again. And so it's zoomable. So this is currently looking at London. We've zoomed in onto Westminster Bridge there, and you can zoom to every area. You can enter a postcode or city, and there are 50 cities across Europe that currently have the data included in our model. And year on year, the amount of available data is increasing, and some of these models, cities, have 3 years of data available for comparison. And many of these cities are within the UK as well. And what this is critically, what it's aiming to do is to show critical pollution indicators for NO2, PM10 and PM2.5. But the most powerful thing about this information is that it's enabling planning and mitigation strategies with the local authorities. And all of this wouldn't have been possible without our partners that have helped to build the model, but particularly the European Space Agency Business Applications, who funded this project, and the portal is an output of that project. So the next case study I'd like to focus on is heat data, which is where we take satellite data to provide the climate change indicators and to support climate mitigation reports and adaptation reports. So showing on the screen is the urban heat island effect. And this is a natural phenomenon where you have dense concreted environments, which generate a lot more heat than the surrounding area, and they'll generate a lot more heat than the blue infrastructure, such as the pond, and the green infrastructure, such as the parks. And so what 4EI did with the satellite was to use the thermal sensors on the satellites to map the heat islands in Bristol in this example. And we pinpointed where those hotspots are in the urban areas. And we looked at where the persistent hotspots were and where there were persistent issues around heat, the effects of the heat islands on the health and vulnerable populations. And what Bristol City Council did is they brought 4EI in from the very beginning, and they included us in their stakeholder workshops, where we were able to learn from the councils about the people who are actually being impacted by these urban heat islands. So it was a two-way learning process. And the council were really keen to understand how the space data could help them. And they used it to drive their climate mitigation strategy into the future. And we also have worked with Climate Ready Clyde. And we took a similar approach, but this time we also factored in population vulnerability data. And this map's actually designed for colourblind people. And the darker areas are where there's a higher level of concentration. And it's called a bivariant map because it's displaying two variables. So the blue is the heat hazard data, and the red is the vulnerable population densities. And what we're interested in looking at is where there are the hotspots of heat hazard and population vulnerability. And so what we did is we focused on the top 20% most vulnerable population in the areas with the highest heat hazard, and we also then factored in whether there was a flood risk as well. And then this managed to focus in on the populations that were not only the most vulnerable now, but will be even more vulnerable in the future with the ever-growing climate change and heat waves. And it was publicised quite widely in the press. So what I'd like to show you is perhaps in the demonstration session at the end, in the networking session, is the actual satellite air quality model portal, which I've got available here to look at today. And we're keen to get this data out to as many people, as many organisations as possible. It's remotely accessible, username, password, and you go. So anybody who would like to take a look at this portal, please come and see me or email me, and we'll set up a demonstration for you. And what I simply did today is I just took a screen grab from the portal of the Technopole, which is marked here in orange, with a red pin. And what the orange is showing is the NO2 levels. And if I'd zoomed out, you would actually see it for different areas of Portsmouth and where it goes green once you're outside of the city environs. This is PM10, and this is PM2.5 particulate matter. This portal also shows the heat data as a layer. And so it's very, very easy just to select the layer that you want, the geographical area that you're looking for, and you can pull the data off. And it's got a really neat little print function so that you can quickly extract the data in a map, can be used in reports, you can extract graphics. And that's it for me. Thank you very much. I've been Suzanne Collins. I've been representing for Earth Intelligence and also Space for Climate. Thank you very much.
Thank you, Suzanne. That was really, really good. And for anybody interested, either here or online, do let us know if you want access to that portal, and we'll get that arranged. I'm quite excited to have a play, if I'm honest. Right, we're now going to be moving to our online speakers. We've got Roland Lee, Technical Director for EarthSense, and Emma Hatton from the Satellite Applications Catapult. So we'll be starting with Roland. Roland, if you'd like to share your slides, please.
Hopefully you can see them. Are they on the screen now?
Give me 2 seconds.
While we resolve that, good morning, everybody. Thank you very much for the invitation to speak. Look forward to saying a little bit about EarthSense and what we do in air quality. My name's Roland Lee. I'm the Technical Director of EarthSense. Can you see my slides?
We can indeed.
Excellent. Good stuff. I'll get going then. Right. Yeah, good morning. I do have an introductory slide. We had some great introductions this morning. I won't say too much other than EarthSense is really focused on the air quality challenge alongside the climate challenge of our management of our environment and the human health impacts of it, as well as the ecosystem health of it. We've heard some great talks this morning already about why we care. EarthSense was spun out of the university 6 years ago. Now, again, we come from a heritage of the upstream of making satellites to measure various different elements of air quality. We used to be involved in trying to make a sub 20 million pound satellite instrument to measure nitrogen dioxide over cities around the world. And it used to be our job to go and promote the economic benefits of satellite instruments and the fact that it gives global coverage. The per capita cost of a satellite service is actually very, very good. It's a great business case for the world to say you've got a 5 trillion cost of poor air quality. You spend 100 million or 20 million pounds on a new satellite service, you get an element of information for every one of your 7 billion, 8 billion people in the world, and you're able to help them. So that's the heritage we come from. We started 20 odd years ago making new technologies for the instruments to monitor nitrogen dioxide. We then had some translational funding from the research councils, as well as from the UK Space Agency and the European Space Agency to say, get these technologies, all the different elements of that portfolio out into the commercial environment. 2016, we launched as a company. Now we're about 25 people, and we've got a turnover of a couple of million. One of the things we did was 4 years ago when the new satellites came out for nitrogen dioxide, we made sure we had a first look at that data. And again, we've had some great introductions this morning. I'm really going to focus on nitrogen dioxide, although we've heard that there's a number of different air quality parameters. There's more toxic pollutants. There's maybe higher profile pollutants in the UK at the moment, PM2.5, for example. But as we've heard, you can measure that with visible imagery. It's a valuable service. I'm not going to cover it too much here. I'm going to focus on NO2. They're the instruments we used to make. It's a great gas for monitoring from satellites, even though you're 700 kilometers away or 30,000 kilometers away for geostationary. You've still got a good amount of information. It's a strong absorber. It's got a nice, clean, independent signal, so you know that you're measuring that particular gas. And it's in the middle of the sunlight spectrum. So as long as you've got sunlight, you've got a good, strong signal to measure. Now, this is the first week of data that came off the newest instrument, the Drawbacks instrument that was mentioned earlier. And you can see the white gaps, that's the cloud. It happened to be quite a good week. So this is relatively good coverage from a satellite instrument for the UK. You can see the kind of resolution we get. It's about 7 kilometers for Drawbacks. It's come down significantly. It could be a kilometer or two in the future. New instruments are coming through that will enable that. You can see the information content there. You can see that the major cities, you can see the impact of changing meteorology, changing wind direction over that week. You get a good amount of information. But actually on a daily basis, that satellite goes over about 9:30 in the morning. You get the information about 3 or 4 hours later. It can't just pipe straight down. So if you're trying to manage a city, you're trying to manage a transport system, that information is, you struggle to use it in its raw state or even its semi-processed state. One of the things that you can just go online and do, and I did this yesterday, is go and pull out last week's average, for example. So you start looking over a longer time period, you get better coverage, you get more consistent information, and that can then, you can understand, was last week representative of the last few years? Was it standard for this part of the seasonal cycle? Do we get the signals we expect? Have the emissions gone up? Has the meteorology done something to impact on our human exposure of pollution? So those statistics are out there and they are freely available for everybody to use. Now, the Copernicus service that is provided by the European Union has a fantastic ability to assimilate satellite data. And we're now designing satellites so that they integrate natively into the models. In other words, the models have a 5-kilometer cell that they work on. You design a satellite instrument that gives 5-kilometer measurements, and all of a sudden that goes straight into the model, and the model understands the spatial and temporal information that it's getting. Now, that is hugely valuable for the operational and commercial environments around satellites, because that means you then have a data feed that gives you an answer everywhere. It pulls in, the statistic is 8 million data points every 24 hours, lots of satellites, 32 satellites last time I looked at them. And that's everything from metadata to surface cover, to air quality parameters near the surface, to ozone layer and the radiative forcing and the amount of heat coming into the atmosphere. All of that is accommodated into these models that we spend tens of millions of pounds as a community to create. And it's then provided free of charge, available for commercial use to anybody out there in the community that has it. So we have that as a background field to our air quality models. It gives there's a global version, there's a European version, and they run at slightly different resolutions, but there's basically an answer for anywhere in the world. And that answer includes a forecast for 3 days or 5 days ahead. And that, again, is critical information, because, again, a satellite measurement will tell you what it was like 3 hours ago if there wasn't cloud in the way and for a large area that might be 5 kilometers wide. But this model will tell you every hour for the next 3 days or 5 days what it's going to be like. What's tomorrow's situation going to be? What can I do to manage the exposure of the population in that area? So model assimilation, fantastic part of the armory, and it's there for air quality services through Copernicus. Now, actually getting services to be used and developed as part of that ecosystem is a bit of a challenge, because people aren't used to buying necessarily model data, forecast model data, particularly satellite-derived forecast model data. But they are quite traditionally used to applying, here's a monitoring point. This is what we understand from our monitoring point. And it was mentioned earlier in that excellent talk of the vertical information of a satellite measurement is challenged, because you're measuring from 700 kilometers away from low Earth orbit. You're measuring all the way through the stratosphere, the free troposphere. You eventually get down to the boundary layer. You've got all of that information to try and interpret before you get to this measurement that should be 1.4 meters off the ground and tells you what a pushchair might be exposed to, what that school gate might have in terms of exposure for the kids that might have asthma at that school, or where they're looking to manage their drop-off, to manage the exposure of children, parents and teachers and everybody involved in that situation. So to actually get to a sort of actionable piece of information for the community on the ground, it's really valuable to have monitoring points as part of that infrastructure and that solution. And it's interesting to note that some of the most commercially successful products that EarthSense has were originally created as a validation point for the satellite data. So we made this box here, and we've sold thousands of these across the world. They're on 6 continents now, and they were designed to validate satellite measurements, to work out, are we actually getting that signal at the ground level that we think we're getting from 700 kilometers away? Are we getting the seasonal trends right? Are we getting all of those assumptions about aerosol and cloud cover right, to the point where we're giving somebody the right information at the school gate? So we have a load of these that we now send out across the world, and it's interesting, the UK, for example, and again, this is quite a UK-centric talk. We had a great global example earlier, but the UK has a network where for every about 250,000 people, you have one well-validated surface sensor. And that was one of my original business cases for, let's spin out a company and do this better, because 250,000 people don't all have the same daily routine. They don't all have the same exposure. They're not in the same bits of the city. They're not all next to the same roads and the same industrial and emission sources. So you need more sensing. You need more ground-based sensing. You need more mobile sensing. And there's more and more equipment, smart cities going into infrastructure, Internet of Things, whatever words you wish to use, that just say there's ability to sense where people are and understand their journey through that complex urban environment and that pollution cloud. So this is just one example. There's a network of sensors gone out over Oxford, and then you assimilate that into a model. You pull all of that information in, the road-based information, the monitoring information, as much information as you can about where people are in that system. And that all feeds into something that can give actionable insight and enable people to improve their exposure profile and manage their particular health conditions. A very simplified architecture diagram. This is simply there to say you pull in a lot of stuff. There's 11,000 reference sites across the world that are reasonably openly available. There's a few hundred in the UK. There's a lot more traffic data appearing now. As mentioned in the previous talk, traffic can be easily 50%. It can be more of the urban emissions that we need to manage, we need to understand. We're getting more and more real-time information in terms of where the vehicles are, how they're being driven. And yeah, fantastic stuff on imagery, getting that real congestion points, understanding where the places are where vehicles aren't moving smoothly and therefore their emissions are significantly higher than the average. You then pull in as much small sensor data as you can. Anything you have out there that you trust that measures pollution well, you pull in your industrial emissions. But that satellite component gives you a really valuable perspective on your picture of emissions alongside meteorology. And it's worth mentioning satellite-derived information for air quality services spans everything from timing from our IT systems that comes from GNSS to positioning from GNSS to metadata, to surface cover, to actually ambient concentration of various pollutants you measure with spectrometers in space. There's a whole range of things we use satellites for as we model air quality. All goes in and then comes out via your standard digital services. And that then produces, we've got various modeling suites. We produce UK annual average information to give people a historic view of how their environment is changing, what policy changes may have made a difference, what individual interventions in cities might have done over the last few years in terms of NO2 and PM 2.5. We have an hourly product that gives 3-day forecasting and an archive out there so you can understand what you might do about tomorrow's situation. And then we get really high resolution city models. I want to just quickly throw in this one. This one is our southern version, and it's got Southampton. We're about to launch this year a new high-resolution model of Southampton. We're going to pull in ship emissions. We're going to pull in really high-resolution coastal meteorology, and that's due to go live at the end of 2022. And that's looking at wood-burning emissions as well in that city. So this understanding of actually our particulate emissions are significantly influenced by people using solid fuel stoves in cities. So teasing out all those bits of information, giving source apportionment, but also giving this spatially and temporally evolving model that has the satellite information, which is fantastic for offshore assets in particular. You really get an idea of what is happening off your coast. But then all of that additional asset information for a really interesting harbour town. So yeah, certainly really interested to talk to anybody in Portsmouth that may want the same, because we're very close and we've got a lot of those parameters being explored this year. So I've now just got 6 case studies, and I'll go through them really quickly. These slides will be available, and please do get in touch if you've got any other questions about them. But I wanted to show a few different applications that we've put satellite data and air quality services to. They're going from simplest to most complex, and then I'll finish. I'll go really quickly. First, COVID. Again, I had a good discussion earlier about the impact of COVID. The challenge in the UK was that actually the meteorology meant that the day COVID lockdown happened would have been a really polluted day, and instead it was only a moderately polluted day. So it made those headlines really hard to communicate. But again, that modeling component let you understand, and that regional picture of all the satellite data coming in, let you really understand what it would have been like. You understood all of the context around the UK and the meteorology that let you say, well, okay, it's moderately polluted today, but it would have been a lot worse had we not had lockdown and had we not taken a load of vehicles off the road. And obviously we were part of the picture of communicating that out to the public. Speaking of public communication, we also took one of our previous annual average data sets, which again had a lot of information from satellites, and we put that on the BBC as part of their postcode service. And there's millions of people have looked at this now. We don't know exactly how many. It's somewhere between 5 million and 15 million people have now looked at their postcode and the air quality for it, whether that's for choosing schools, choosing houses, or just understanding the health impact of living in a certain area. So that's been a fantastic resource. It just shows how much the public, as well as various other organizations out there that use this, are really thirsty for this knowledge. It's information that we need as a community, and making it available and making it available via portals and via easily accessible and understandable means is a critical part of this. And it can be a criticism of satellite data in the past that if you were a scientist or you're part of a university or a deep industrial facility with good R&D, you could go and pull out that satellite information and make use of it. We need to make that tangibly usable for members of the public. This one is for house buyers. We've got tens of thousands, hundreds of thousands of house buyers reports now. So people looking at buying new houses, we tell them what the air quality is for that property as part of their standard information pack. This example is a fascinating one because it's using faith centres as a way of communicating in diverse communities the challenges of air quality and the behavioural change nudges we need to improve both air quality as a whole as a community, but also individual exposure and how we manage that exposure. And it's been a fantastic example for Sandwell. There's a load of sensors out there and there's communication around the sensors, but there's also critically the model with the 3-day forecast, which is heavily satellite informed, that tells people this is what tomorrow is going to look like. And then those faith centers can help to communicate to communities. These are the things you might do to reduce the impact of tomorrow's effect on you and your wider communities. Fantastic project, currently ongoing. This is one in Leicester, more one for future looks if you want to have a look, don't bother reading for now, but it's all about wood burning smoke. It's about understanding how much people are using their stoves. And we produced an app for this one that we put out in the community to say, this is when you really try not to use that wood burning stove unless you absolutely have to. If you need it for heating, fair enough. But if you're just using it for pleasure, tonight's a bad night because inversion layers are low, the pollution's going to get trapped and you're going to be ending up increasing the particulate loading for you and your local community. So really getting that message across to just help manage that temporal use of emission sources, because there's various things we do that help our quality of life and our transport, but there's times when it's okay, when there's a gale going by and the pollution just disappears and nobody gets hurt by it, and there's times when actually that makes a big difference to the community around you. So starting to get a little bit more complex now. This one is the example in Oxford that I showed earlier of that network. Here we were using a real-time traffic model to give traffic managers guidance in real time as to what they could do. And that included variable messaging signs on the road. So big things saying, take this route, not that route, because this route's really congested and it's going to get really polluted. So please try and take this route because it's clear. Messages on the local radio, all the way down to closing lanes and roads to just help direct traffic around. But it also had incident support. So when there was an accident on the M40, for example, and you knew there was a big influx of traffic around one bit of the city, we would be modeling that. In 4 minutes, we'd give 16 scenarios of different ways you could manage that city. And then within the 15-minute management window that they operate on, they could decide which of those scenarios to go with, run with it, and then we'd give them the next 16 scenarios for the next 15 minutes. Really good example. And again, just pulling that satellite data through, making sure it's usable for actionable insight and operational systems is the critical piece of the puzzle. The final example, this one was up in Leeds, and it was an Innovate UK funded one. And this time we were actually changing an HGV. So HGVs are really difficult to run clean. They're big, they're heavy, they're not easy to just put an electric motor in, but you can do range extended. So you can have a generator charging electric motor and you can run for about 1 kilometre on pure electric when you need to. So it's really critical when you're looking at logistics in cities to get it so that you understand where the harm is going to be from those emissions. So what we had was a real-time model running. We did all of the computational fluid dynamics around buildings. We understood where the hotspots were, and we told trucks, today's a bad day. You're about to go into a hotspot that might have school children in it, and it's certainly going to be polluted. Use that 1 kilometre of clean movement now, because it's going to make the most difference. And we then sent that in real time to the vehicle, and it changed its thing. So again, that's the technologically most advanced thing we've done so far in terms of changing vehicle behavior and the drivetrain on a HGV in real time. So a quick summary, and again, these have been covered quite nicely earlier, but satellites, they're a single instrument. They are 700 kilometers away. Understanding what's happening to them is sometimes a real challenge, but you generally have one team. You spend a lot of time making them. They cost millions of pounds to make. You have a talented team of experienced engineers that know what they're doing when they're making them. And then you have a really good team of multinational efforts, communities validating just one instrument, thinking about, has the lens deteriorated? Has my detector deteriorated? And that just gives a good answer for the whole world, or at least a unified answer for the whole world. So all of your global trends are unified. You then spend it once and you get global advantage. And this is you spend £100 million on the satellite mission, and you've got a £5 trillion per year thing that you're trying to manage. It's only a small piece of that puzzle. You've got a little bit of evidence that goes into a larger system that then builds into systems that actually reduce the pollution and don't just tell you about the pollution. But it's as a part of that answer, £100 million is very worth the money if you can get the global community to invest in it, which thankfully generally they are, but more is always better in this case. Global coverage, if you've got low Earth orbit, you get over the world every day, twice, but only once you have sunlight. But if you don't need sunlight, you get 2 measurements a day. And there's no ground-based infrastructure to manage, as discussed earlier. So some places in the world, ground-based infrastructure is easy. You've got power, you've got comms, you've got security. You can put an instrument in there and you get that really nice resolution information that you feed into your models. Some bits of the world, that's more challenging, and it's great to have that global coverage. Clouds get in the way. As mentioned, as discussed, you can't be sure you're going to get a measurement on a given day. Surface measurements heavily derived. You've got all of that information in between to try and work out what's actually happening at nose height for the average person. Resolution relatively poor, nearly always over 1 kilometre. That will come down, but there's a fundamental challenge. You're going 7 kilometres a second in low Earth orbit. So you've got 1/7 of a second to get every bit of information you need on your 1 kilometre square. And that's a real challenge when you're doing spectroscopy with that information. And then relatively few measurements per location per day. Now, Sentinel-4 in 2023 will improve that. Geostationary satellite giving air quality data will give us a measurement every 15 minutes over the day. That'll be fantastic and change the way we view the temporal information content available from satellites. So we're looking forward to that. Thank you very much for your attention. Really look forward to any questions that might come at the end. Thank you.
That's lovely, Roland. Thank you very much for those insights. Some beautiful images, and I think I should be slightly concerned about house prices. They're going to start taking into account air quality, especially as I live near a motorway. Okay, right, Emma. Roland, if you'd like to stop sharing your slides, and Emma, if you want to start sharing your slides.
Okay. Just bear with me 1 second and let me get that sharing. For some reason, it's not at the beginning. There we go. Right, then hopefully you can all see that screen. Was that a no?
No, that's a yes, we can.
Okay. The other thing, I will just hopefully have enough time to share my video. I think I've put that on to share the sound. If not, I can always go back and do that. Okay, good morning, everybody. I'm Emma Hatton from the Satellite Applications Catapult. I am a satellite solutions architect working for them, and I try and help enable businesses and other value streams within the Catapult to integrate satellite data, Earth observation data specifically, into the solutions that they're developing. I should add my area of expertise isn't in clean air and the satellites for clean air, but I am learning increasingly more about them as they're becoming a larger part of our solutions. So to introduce the Satellite Applications Catapult, the mission of the Catapult is to innovate for a better world empowered by satellites. And we are an organisation that is partly funded by the government and is independent, and we're trying to help other organisations to grow their businesses. We work across a variety of different parts of space, so looking at ubiquitous connectivity, so sensors that are satellite connected or connected to 5G networks, for example, geospatial intelligence, which is the team that I work in, and also access to space that is supporting companies who are looking to launch satellites or prototypes. So covering Earth observation for clean air, you've already had fantastic introduction today to this, so I shall only be adding a limited amount of information, I think, to what's already been discussed. Our role within the Catapult in geospatial intelligence is to try and increase the use of Earth observation data in everyday decision making. I think one of the challenges that we face is that people don't think that space data is necessarily the right answer for their solutions. They think of it as something different, something sort of expensive and unnecessary potentially. But one of the things that we're trying to do is increase that use and try and break down those barriers to make sure that space is more accessible, and maybe that data is treated as another source of data for people instead. So in the geospatial intelligence team, we work across a really wide range of different sorts of challenges, and many of these, you will notice there, do actually have some sort of impact on the environment, on potentially on clean air. So looking at projects on renewable energy, air pollution, urban development. There's a wide variety of products and services and techniques that we work towards and that we are supporting to help this particular area. So what is the role of satellites in clean air? As mentioned previously, I think it is really important that we're able to try and measure the role of the air quality over large scales. So we can have in situ sensors that are placed within towns and cities. Predominantly, we find them, I think, placed along motorways, a few of them in the cities, but what they don't do is provide information that connects the pollution with, as we've mentioned, what is happening in the current time and what is happening with the weather, for example. So looking at the motion of polluting events and how they're impacting on cities, how pollution is sort of flowing around areas is really important. And Roland's presentation shared really nicely just now, looking at that sort of fluid dynamics of the air pollution around cities. So the ideal really is to have a look at a hybrid approach that combines satellites and local sensors, and that enables you to develop solutions that are looking at the widest area down to a really granular level of detail. Covering a couple of the satellites, they've already been mentioned before. Copernicus 5P, which we're looking at, has a resolution approximately of 6 by 4 kilometers. So this is a satellite that has quite a coarse resolution. We have a look at these 3 satellites, where Sentinel-4 is the one that impacts us in Europe. These are 3 satellites that are in geostationary orbit, so that each one is always looking at the same area. And Sentinel-4 provides information at a spatial resolution of approximately 9 by 9 kilometers. And this provides, as mentioned previously, a variety of different measurements across Europe. But as you can see, it enables you to actually see if pollution might be blowing in from overseas, depending on the direction of the weather as well. We've got another example here. This is the Pulse service by GHGSat, and they have they're a commercial service, as mentioned earlier, that has satellites, and they're developing a constellation to try and measure methane emissions and other greenhouse gases as well. And they've got this free service which provides a 2 by 2 kilometer square monthly average across the globe. So you're able to have a look at monthly averages for any location, and what this is measuring is it's not exact methane concentration, but it's relative methane concentrations compared to other areas. And this service is provided for free, but they also provide much more detailed information that goes up to, or should be going up to, 25 by 25 meters. And there, for example, this allows detection of specific events that are causing pollution, where there's a sudden release of gases. There is an image, and there was a report done about methane coming from Spanish landfill sites, and there was a little controversy there because the Spanish government have claimed that they were managing the methane well, but this does enable the detection of events like this. I think the important thing here is obviously, if something like this is being integrated into a solution, that it is done in such a way that there is, I suppose, the governance of what happens with that data is actually considered. So covering a quick case study. the Satellite Applications Catapult has been involved over a number of years with a project called Innovating for Clean Air. And this has centered over having a look at clean air in India, particularly in the city of Bengaluru. And it has been a really wide project covering a number of different partners. And actually, I think the best way of explaining this is to cover a video, which hopefully I've pressed all the right buttons when I was sharing so that you can hear the sound. It's only 2 minutes long, so I'm not going to keep you for too long. And let's keep our fingers crossed that you can hear this. If you can't, can somebody please advise me quickly and I will reshare it with the right selection.
Did you know that around 23% of energy-related gas emissions are...
Were you able to hear that? Sorry.
Yes.
Yeah, perfect.
thought to be produced by transport? At a time when cities over the world are facing challenges related to air quality, reducing internal combustion engine vehicle usage could be the key to improving air quality in India and across the world. Under the Newton-Baba partnership, the Innovating for Clean Air program was funded by Innovate UK, a part of UK Research and Innovation. It was delivered by 3 organisations in the UK's Catapult network, that is, Energy System, Connected Places and Satellite Applications, working with the Indian Institute of Science and Department of Urban Land Transport in Bengaluru. Together, these partners have developed testing and demonstration opportunities for innovative EV and air quality technologies and strategies. The program began in 2019 with partners identifying critical EV and air quality challenges in Bengaluru, India. Following this, they engaged Indian and British SMEs to deliver innovative solutions through urban test beds. This project has helped develop a business ecosystem to address the challenges of air quality and to bring about EV transition in Bengaluru. Working together, the UK and India has unlocked 10 pilot projects and signed 5 MOUs to launch new partnerships between UK and Indian organizations. Thanks to the project, over 20 Indian and UK SME businesses have kick-started green and clean solutions to scale up. Ultimately, this is helping the development of a range of solutions to air quality and climate challenges. As the world attended the Conference of Parties that addressed global climate issues, the IFCA project served as a showcase for innovative UK and Indian solutions working together to tackle climate change in the future.
Thank you. Right, I'll carry on. Oops, sorry. Right, finally, I wanted to cover a little bit of information about opportunities for support that the Satellite Applications Catapult has got. And we are able to help support companies through a 6-month project at the moment with the Space Commercialization Engine. This is a newly set up opportunity with it's based at Space Park Leicester, but it's open to companies from around the UK, and it provides an opportunity to start with a business sprint, have a look then at the next 2 months working on a sort of a feasibility study, followed by 2 months of prototype development, and then finally having a look at commercialization and next steps for the idea. Ideally, it really seems to be best suited to companies that are looking to bring an element of space data into a business, a sort of fairly well-formed business already. But it is open to anybody. It's just that those seem to be the places where it seems to be working the best. We also have opportunities through what's internally been called Explore and Evolve. These are funded through a variety of different mechanisms, but the key support that is provided is a business sprint package. And so this helps companies that maybe are more technology driven and have developed or potentially spun out from universities. It helps them to develop a sound business case and steps towards commercializing the technology that they have developed. Finally, we're also, for any companies that are involved in ESA business incubation, companies, we are able to provide some technical support for them as well. So that is an option where that support can come from the catapult rather than directly from ESA. And of course, for any larger companies as well, we're also in a position to arrange bespoke support packages to try and help integrate Earth observation more widely within a business as well. And that is the last slide for me. So hopefully I haven't kept you too long, because I know that we've run over a few minutes. Thank you very much, and I'll pass back now.
Thank you, Emma. That was fantastic. Hopefully everybody can see me online there. I'm conscious we have run over today, so I'm just going to put it down to one question, and then obviously anybody can follow up offline separately. So my question, I'll go through all the speakers one by one. It's the same question. You know, what does the future look like for using satellites and air quality? So Olusegun, literally in a sentence.
Yeah, it's going to be revolutionary with the new sensors coming on board now that can provide the final resolution of 10 kilometers, 6 kilometers, but that would be amazing.
Okay, so you think it's all about the sensors?
Yeah, about the sensors, yeah.
Fantastic. Same question to you, Suzanne. You know, what's the future going to look like? What should we be thinking about?
I think it's about actively using the data. So there's so much available data, and it is coming through in formats which are so user-friendly now that, and that should be an everyday occurrence that people are bringing that into decision-making processes, whether it's a local authority, an organisation, or an individual. With a home buying report was a fantastic example of that.
Thank you. Roland, are you able to give us your thoughts?
My answer would be better data, better services, better policies, better decisions, and better health outcomes, hopefully.
Fantastic, thank you. And last but not least, Emma.
I think from my point of view, I'd like to see holistic approaches that are really looking at tackling the actual problems to get end-to-end solutions developed.
Fantastic. Right, thank you very much to all our speakers. Thank you to our attendees, both here in person, at the North East Centre, and obviously at home to our online audience. I think it's been a fantastic session. We've heard everything from, you know, why we should be interested in air quality, what does it mean for our health, what those technical solutions look like, what data is available, and how we can be utilising. So I think there's plenty to think about. So I will leave it at that. We will be sharing slides with all our attendees, and we will be making the video available on our YouTube channel in the next day or two. So apart from that, thank you very much, everybody. Enjoy the rest of your day.
Thanks, Luke. Thanks, Chloe.
Thank you.
Thank you.